The pager went off, but not for the thing that was actually breaking. The alert was for CPU usage. It had crossed 85% on a subset of nodes. Nothing unusual. We had seen that pattern before during traffic spikes. At the same time, Slack messages started coming in. Users can't upload files. Uploads are timing out. Anyone looking at this? We checked the alert. CPU. That was what woke us up. So naturally, we followed that signal. And that was the first mistake. Environment context. We were running on AWS with Kubernetes on EKS. The platform handled media uploads for a web application. Images, videos, documents. Everything flowed through an upload service exposed via an API gateway. Traffic averaged around 2,000 upload requests per second during peak. Uploads were handled by a dedicated service that streamed data to S3. Metadata was stored in Postgres on RDS. We used Redis for short-lived session tracking. Behind the scenes, uploads were processed using Kafka. CI deployments were handled via GitHub Actions and Argo CD. Monitoring included Prometheus and Grafana dashboards. We also had application-level metrics. Alerting was primarily based on infrastructure metrics: CPU, memory, and node health. Initial symptoms. Users were experiencing failed uploads. Files would start uploading and then stall. Eventually, they would time out. But the API responses were inconsistent. Some returned 500 errors. Others returned success even though the upload never completed. Looking at the dashboards, CPU usage was elevated on a few nodes. Memory looked stable. Pod restarts were not increasing. Error rate was slightly elevated, but still below our alert thresholds. Latency had increased, but not dramatically. Everything looked like a mild degradation. Nothing screamed critical failure, except the user complaints, investigation, and escalation. We started with the CPU alert. Maybe the nodes were under pressure. We checked pod resource usage. So we scaled the deployment, added more replicas, spread the load. CPU usage dropped. But the problem did not go away. Uploads were still failing. That was the first signal that CPU was not the real issue. Next, we checked network throughput. Uploads are network-heavy operations. Maybe bandwidth was saturated, but network metrics were normal. Then we looked at S3. Upload requests were reaching S3, but completion rates were inconsistent. Some uploads were incomplete, some missing entirely. We dug into the upload service logs. There were warnings, timeouts while writing chunks, retries happening more frequently than usual. Still not enough to trigger alerts. We then looked at the Kafka queue. This was where upload chunks were tracked for processing, and that is where things started to make sense. The queue depth had increased significantly. Messages were piling up. Consumers were not keeping up. Root cause. The cause was back pressure in the Kafka consumer layer. A recent deployment had introduced additional validation on each chunk. This increased processing time per message. As a result, consumers fell behind. The queue started growing. Uploads stalled. Because the service returned success once the initial request was accepted, many failures were not reflected in metrics. CPU was just a symptom. Mitigation and recovery. The immediate fix was rolling back the recent deployment. We reverted to the previous version of the consumer. Processing speed improved almost immediately. Queue depth began to decrease. Uploads started completing successfully again. Within about 30 minutes, the system stabilized. User reports stopped. Metrics returned to baseline. Post-mortem reflection. What actually failed was our alerting strategy. We alerted on CPU usage, but CPU was not the user-facing problem. It was just a side effect. The real issue was queue lag, but we had no alerts for that. Success responses were misleading. We followed the alert instead of the user. Engineering lessons. Alerts should be tied to user impact. Queue depth and processing lag are critical signals in asynchronous systems. Success responses should reflect actual completion of work. Metrics should capture end-to-end outcomes, not just service health. The most important signal is often the one users are already telling you. And if your alerts are not aligned with that, you are solving the wrong problem.